Our next lesson in geometry is called deductive reasoning. But let's review a little bit first. Whenever you make a conclusion based on a few samples, what is that called? Okay, inductive reasoning. How do you prove how do you disprove a conclusion that you made with inductive reasoning? Okay, you only need one example to prove it wrong. Okay, what is that example called? The example that proves your conclusion wrong, what's it called? Okay, counterexample. Alright, well today we're going to talk about deductive reasoning. Our goals for this lesson are to identify the major and minor premises of a syllogism, and draw conclusions from premises. Our vocabulary word: the process of making a conclusion by fitting a specific example into a general statement is deductive reasoning. Let's go ahead and skip a space in your notes. Write today's dates. And this lesson is called deductive reasoning. Okay. In using deductive reasoning, we start with general statements that all agree to be true. Postulates, definitions. We then look at specific examples to see if they fit the conditions, premises. If they do fit the conditions, then we should logically accept the results, or the conclusion. The test is really to determine the validity of the postulates, definitions, and premises. Okay, for example, Thanksgiving is on Thursday. That's a premise. It's my general statement. Is Thanksgiving on Thursday? Yes, Thanksgiving's always on Thursday. That's true. Okay. What if I say today is Thursday? That's my premise. Well, if today is Thursday, that would be true. What if I say today is Thanksgiving? Since today's Thursday, it's Thanksgiving. Conclusion, well, maybe, but probably not, because you're at school, so that's probably false. Do you see the difference between inductive reasoning and deductive reasoning? Inductive reasoning took general observations and attempted to arrive at specific conclusions. Deductive reasoning attempts to take specific observations and create a general conclusion. Deductive reasoning is used in geometric proofs. Alright, here we go. If a bug has 6 legs and a 3-part body, it is an insect. My pet Wiggly has 6 legs and a 3-part body. Conclusion: Wiggly is an insect. Okay, that's true. Okay. Okay, what if A equals B, then AC equals BC? We know that's true because of one of our rules in algebra. That's if you multiply both of them by the same number, they're still going to be equal. Okay, so B is 6. Okay, I'm sorry. I'm getting ahead of you. Okay, let's say A equals B. Then AC equals BC. And we know that's true because if these are equal and we multiply them by the same number, we're going to come up with, they're still going to be equal. Now if I say B equals 6 and C equals 3, okay, conclusion is, well, B is 6, then AC equals BC. Okay, then A times C is 3 equals B is 6, C is 3. So this is 3A equals 18. We said A equals 6. It says 2 times A equals 12. So if I multiply both of these times 2, 2A equals 12. Okay, that's true. Okay, now that's deductive reasoning. We proved it. Okay, a rectangle has 4 right angles. A square is a rectangle, so the conclusion is a square has 4 right angles, and that's true. And this is what geometry is all about. You take the principles that you know and apply them somewhere else. Okay? Here's another example. All geometry students have studied algebra. You are a geometry student, so the conclusion is you have studied algebra, and that's true. Although you may not know anything about bugs or rectangles, deduction is with no guessing involved, tells you that if statement 1 and 2 are correct, then the conclusions shown are also correct. This process is using deductive reasoning. You should recognize this type of logic from our lesson on conditional statements. Observe the truth table. This is in your notes, so you don't have to write it, but you have this truth table. It's a conditional truth table. Here's P, here's Q. If P, then Q, or P implies Q. We said if P is true and Q is true, then the condition's true. If P is true and Q is false, the condition is false. If P is false, it doesn't matter what Q is. It's true. The condition is true. Okay? Note, in each of the following exercises, the first 2 statements are accepted as true. Okay? So deductive reasoning is when we take taking true statements using true statements to find conclusions. Okay? Alright. Let's do a few of these together to make sure you're understanding this. Okay. Number 1, if the mill is on strike, then no one works. Number 2, the mill is on strike, so what is your conclusion? Okay. If the mill is on strike, then no one works. Number 2 says the mill is on strike, so what is your conclusion? Well, it told you that if the mill is on strike, no one works. So if the mill is on strike, your conclusion would be no one is working. Alright? Let's do another one. If a figure has 4 equal sides, then it is a square or a rhombus. Okay? Number 2 says the figure has 4 equal sides. So what is your conclusion? Okay, number 1 said if a figure had 4 equal sides, then it is either a square or a rhombus. Number 2 says the figure has 4 equal sides. So your conclusion is it's either a square or it's a rhombus. Right? These aren't hard. All you have to do is listen. The answer is stated in it. You just got to listen. Number 5. Okay, the first part of number 5 says if 2 planes intersect, their intersection is a line. Number 2 says plane R and plane S intersect. Okay, so if two planes intersect, their intersection is a line. And 2 says plane R and plane S intersect. What is the conclusion? Okay, the conclusion is plane R and plane S intersect in a line. It's important that you stop the tape and try to answer it before I do, because in a minute you're going to be doing this by yourself. You need to make sure you're understanding it, okay? Here's one. Number 7, all rabbits eat lettuce. All rabbits eat lettuce. The second part says, my pet is a rabbit. What is your conclusion? All rabbits eat lettuce. All rabbits like lettuce. My pet is a rabbit. Okay, the conclusion is, my pet likes lettuce. We'll try one more, then I'll let you do the rest of these by yourself. Okay. Number 1 says, if a triangle has a right angle, then the triangle is a right triangle. Okay? Number 2 says triangle ABC is not a right triangle. So what is the conclusion? If a triangle has a right angle, then the triangle is a right triangle. The conclusion says triangle ABC is not a right triangle. So your conclusion should have been triangle ABC does not have a right angle. Alright? Now I want you to go through and do the rest of these problems.